Welcome to clickmyproject.com. Now let me discuss about lossless compression of hyperspectral images using cluster linear prediction with adaptive prediction length. We propose this novel method to compress the hyperspectral image without loss of any information. To compress the image, minimum description length or adaptive entropy predictor are used. Normally the hyperspectral image contains the different spectral band. These different spectral band will be separated in pre-processing. The separated band will pass to the integer wavelet transform. It will transform the image from the spatial domain to frequency domain. After transformation, we apply the minimum description length adaptive entropy predictor. It is a technique from algorithmic information theory which dictates that the best hypothesis for a given set of data is one that leads to the largest compression of the data. We seek to minimize the sum of the length in bits of an effective description of the model and the length in bits of an effective description length of a data when encoded with the help of the model. After encoding the image, the encoded image will be given to the inverse minimum description length adaptive entropy predictor. It will decode the image. After the decoding, we will apply the inverse integer wavelet transform. Finally, we get the reconstructed image. This is the flow of our project. Here we have to provide our hyperspectral images. The provided hyperspectral image is passed to the integer wavelet transform. It is an invertible wavelet transform that makes integer to integer. The integer wavelet transform is mostly used for the lossless compression. It combining the lifting construction with the rounding of in a reversible way. This approach builds upon the idea of factoring wavelet transform into lifting steps. Build the integer version of every transform. The transformed image is passed into the decimate into each subbands. Here we are separating each spectral subband from the hyperspectral images. For the separated hyperspectral images, here we are applying the minimum description length adaptive entropy predictor. It is a technique from algorithm information theory which dictates that the best hypothesis for a given set of data is the one that leads to the largest compression of the data. First, estimate the correlation between the current pixel and the neighboring pixel. Then we collect the samples in the part of the image and from a training set of pixels, the content sufficiently matched to the corresponding samples. The encoded images will be stored in a compressed image. After the encoding part, here we are going to the decoding part. In decoding, the encoded image is passed to the algorithm. Here, the inverse minimum description length adaptive entropy predictor are used, which is used to decode the image. After the decoding, it is passed to the inverse integer wavelet transform. After the inverse integer wavelet transform, it will pass to the reconstructed image. Finally, we get the reconstructed output image. Now let's see the execution part. Normally the hyperspectral image contains the different type of spectral bands. Nearly the hyperspectral image contains 31 bands, so it will take more time for the execution. So now I am showing the demo for the 2 subbands. I am selecting this is a HSI compression is the main file. Select this file, right click, run the file. The guide window will be open. Here we have to select our hyperspectral images. In dataset, totally I am having 5 images. Now I am selecting one hyperspectral image. These are the different spectral bands of the hyperspectral images displayed here. Here we are separating the each bands in the hyperspectral images that are plotted in the figure window. it will take more time for the computation. After subbanding, the hyperspectral image is passed to the integer wavelet transform. This is the reconstructed image. The image is passed to the integer wavelet transform. After that, minimum description length adaptive entropy predictor algorithm is used for the compression. After the compression, it will pass to the inverse minimum description length adaptive entropy predictor. After that, it will pass to the inverse integer wavelet transform to finally reconstruct the images. Here, the one band compression and decompression is completed. Here it is executing the second band compression. Now execution is finished. This is the second band reconstructed image. This is the image obtained after the subband coding. This is the compressed image. This is the input image, second band image. This is the compressed image. This is the provided input image. Here we are showing the hyperspectral image by the use of hyperspectral image compression by the use of minimum description length adaptive entropy predictor. It will provide the lossless compression of the hyperspectral images with the use of integer wavelet transform. Thank you.